Good morning. I think I'm going to do a kind of a chilled out live coding this morning. This is not wildly attacking some new feature and some new technology. This is going about the quiet business of maintaining software, which is very important and very pleasant, but doesn't require a lot of adrenaline necessarily when it's going well anyway. So we're gonna just relax and enjoy our morning. I'm just going to make sure over on another window that everything has come up properly. Bear with me for a moment. Yeah, that looks fine. YouTube has posted this in the right place, which is nice. So actually, we're going to start a little bit indirectly with an Emacs hack. I haven't done an Emacs hack in the longest time, but well, I prepared a to-do list of my kind of goals for this session. And I often start these live coding sessions with a list of goals that kind of pop up, but then they disappear. I only show them on the screen for a minute or so, and I thought that's a pity. It would be nice to show this all the time, and that's why I added down the bottom here, in black on gray, I added a little status line. So what I was thinking is we could start off making a list of goals, and then we could always show what the current goal is, so that if someone's coming along to these videos and hopping in at a random point and skipping around and trying to find the relevant, interesting bit, then it will always be shown at the bottom. I thought that might be a nice incremental step. It's nice to do small incremental changes. So I figured I already have this list of goals right here in Emacs, and I'm already kind of popping it up and checking them off as we go normally, just informally. So why don't we extend Emacs to be able to just be able to set that? And as you can kind of see there, the contents of the string is read from a file in my home directory. So all Emacs needs to do is actually write something to a line, to that file, and it'll automatically appear there. It should be anyway. So I'm just going to do that first, and then we're going to go and we're going to open a pull request from the Snabb next development branch towards the master branch. We have a lot of changes queued up for the next release. We're gonna formalize the idea to merge those with a pull request, and that's gonna automatically be tested by our continuous integration system. We're also gonna see if there's any more changes, maybe not last minute, but things that are merging at the last minute that should go into that release candidate before the tests run. Maybe we should even reverse those two steps. We might reverse those so that we don't do unnecessary tests, have to wait. And then there's that. I would also like to update the RaptorJIT branch for Snabb, because I really want to merge RaptorJIT into Snabb next month. And I'm going to this FOSDEM conference on the weekend and meeting a lot of Snabb hackers, some of them for the first time. And I want to have that in a good state to be able to talk about and demo RaptorJIT and all the studio tooling and that kind of thing. So first things first, let's write an Emacs function to write this OBS status file. Okay, so there's the file, and if we write foo bar and then save that, yes, then it updates down there. So updating the contents of that file does change our little status line. So now all we need is an Emacs function to do that. So why don't we open my .emacs? I used to do a tremendous amount of Emacs hacking, but I haven't written any Emacs Lisp code in I don't even know how many years. But this should be simple enough. All we want to do is get the current line. To start with, we won't even bother skipping over that and just write it to a file. Okay, so how do you get the current line? We'll do a search for a function. Line, something like. I only really wanted functions. Wow, I'm rusty on my Emacs. What does that give me? No such function. Anything like that? No. That gives us the character position where the line starts and the character position where the line ends. This is incredibly roundabout, of course, but Okay, that's that has given us. I'm sorry, you can't see my whole Emacs window there because that status bar is obscuring things. Pull that up so we can see. Yeah, so we get the current line. That's with all of the syntax coloring included. So if I recall correctly, when I say buffer substring no properties, fine. Okay, so let's define a command, and we'll put this at the top. Why not? The command will be update live stream status. This will be an interactive command with no arguments. Interactive just means that you can call it as a command. It's not a subroutine, it's a command. And we will. What we're going to do is make the current line be the live coding status, and we will get the current line in, I'm sure not the best way, but the way that we just did it before, which is like that. And now we want to write a string to a file. So how would you do that? This writes a buffer into a file, but in our case, we don't. Do we want to do this as a buffer? We could actually just open. That might be. It might be the most Emacsy way, would it be, to actually load that in? See if there's an easy way. I'd be pretty happy to just write a string into the file. If that's something we can do. Maybe it's not. Okay. Let's take a different tack. No, we'll continue on that tack. So line is then, for now, let's just say message. We are supposed, status should be let's give that a key binding. Control C. Oh, it's going to be for no particular reason. Not accepted. Why not? I Control C. Like that. Wrong number of arguments to define key. Oops, I need to say the command. Update live stream status. Okay. I just ran it and it said the status should be, and then it gave the contents of the current line, which is good. That's what we wanted. Okay, so then how are we going to write that? We might just save excursion. As I recall, we'll remember which buffer we're in, so we can switch buffers here without causing a stink, without having a user visible change. A lot of Emacs stuff is like that, just digressing ever so slightly. A lot of Emacs stuff is based on side effects and controlling those side effects. So here we say, just remember where we were, and then we're going to go in and change switch buffers, which is convenient, and it'll automatically kick back to the original one later, which is really nice and convenient. Let's got one eye on the health of my live stream. It seems to be not that good. Hopefully it's coming back. We'll see. Sorry about that. Okay, we're going to find the file that we wanted, which was... I think it was that, right? Where are we? It was that. Plonk that out of our messages buffer and go back to where we were. And then switch into that file, and then what do we want to do? We just want to replace the whole we want to just replace the whole contents with this string. I'm sure there's a better way to do this, but as I say, I haven't done any Emacs hacking in years and years, and this will get the job done. So how do we nothing for buffer replace. erase buffer. That sounds like a good start. And then we can just insert the line, and then we can save. When you press Control X, save buffer. And what is the arg? Fine. Let's see if that could possibly do the job. Now, so when I press Control C O, it is supposed to look at the current line that I ran the command on, see what the status should be, and then in a temporary context, it will get rolled back. It should switch to this file, erase the contents, insert the line, and save it. So let's see if that happens. We want to go into our streaming to-do list. So if we run the command now and look at the gray status line at the bottom of the screen, what happens? Yeah, okay, that worked. That's nice. Okay. I guess it would be a nice touch to remove that little minus sign, right? But I think that this is going to get the job done for now. For now, the nice thing is that if you hop onto the stream at any random time, you'll see what's going on down there. And if it's not clear what that means, that is our current goal, our current thing we're focused on, then we can come back another time and improve that. Fine. Okay. In that case, we're done with that, and run our command again. We are now pulling the last changes into Snabb. When it switched me into that buffer, I don't like that. I thought the save excursion was gonna not do that. Sorry, pardon me. Yeah, never mind. We'll hack the Emacs code another time. We won't do more on that now. Okay, so actually, we're gonna do this in we're gonna do these two a little bit relatedly. So the first thing I'm gonna do now is I'm gonna kind of pre-open a pull request on GitHub, but I'm not actually going to submit it until we've had a chance to merge some more changes. But as a first step, just to see what it is we're releasing, I'm going to do that. So let's get a browser. We're going to do this on GitHub. On Snabb, we use a Git workflow that's basically like the Linux kernel. It's the distributed workflow in which we have a master branch, which is something like, well, the master branch is a release branch. Code only goes onto the master branch in order to be released. So a push to the master branch is a release of Snabb, and a pull from the master branch is to get the latest release of Snabb. That's what the role of the master branch. We also have a branch called Next, which I'm maintaining, which is just accumulating all the changes that should go onto the master branch in the next release. And we normally have a monthly release cycle. We're not always on target for that, but generally we make a new release every month that collects together all the changes that are supposed to land on master in that time frame. So. And then down from that, people are submitting pull requests on GitHub with changes that they're making, and we have multiple maintainers, me and Andy Wingo and Max Rottenkolber and other people. We're the most active ones right now. And basically what happens is everybody's maintaining a branch, and the way the changes come upstream into Snabb is that some maintainer says, okay, I'm interested in that change, I'll engage with the person who submitted it and make sure it's okay, and then pull it onto my branch, and then I'll pull request that branch the next step. So you might make a pull request on GitHub, and maybe Max engages with you and makes sure that change is okay, and then he pulls that onto his branch, which is called Max Next. And then when he's batched together a satisfying amount of work, he might send that over to the next branch, and then I give it a sanity check fairly briefly, because we've all been working together for a long time now, so it's not a lot of pushback usually on. But anyway, I'm a second set of eyes on that and pull it onto the next branch, and from there it gets mostly people can look at it and test it, and it can get hammered with CI, and then from there, when it's ready as a release candidate, it goes onto master. So the state we're in now is we've got some stuff on the next branch, and we might have some more stuff on some of the downstream branches that we should pull up. We're just going to get an eyeball on what we have on next right now. What is the stuff that I already merged from Max and Andy earlier in the month for the release, and which will be partly some things they wrote themselves and partly things that they merged from elsewhere. So I just clicked the wrong link. We'll go back and we will go to branch next. Here, and we will make a pull request from next to master. And that's kind of the way that you that I would advertise a release candidate, or some code that is in the process of being proposed for release. GitHub is running my internet is running very slowly for some reason. I'm not sure why. I'll briefly check on that in another window if there's any satisfying explanation. I don't know why. Oh, hopefully it will do. Okay, so this is a pull request. This is the thing that we're gonna submit today. I'm not gonna do it. I'm not gonna actually submit it quite yet. I'm just gonna see what it would look like. Next, changes queued for the 2018.01 release. I'm a bit late. I'm sorry, everybody. I'm a bit late. It's the last day of January, and here we are preparing the first release candidate. So it'll probably come out in very, very early February. But that's okay. It's within tolerance, I would say. These changes are queued for next release. Now, what do we got? We have 694 commits coming in, touching 305 files. Sorry. Sorry, 694 commits coming in, touching 305 files. It's quite a bit, and we can dig in and see where these changes come from, and we'll do that. We'll do that in an Emacs with Maggot. I want to see a log from the master branch to the next branch to see what changes are queued. So this is looking at the graph of all the changes that came in this little ASCII graph view. So here we see that here's where I merged a batch of changes from Max. Now we see Max, he had some IPsec interoperability thingy here, IPsec test code, so some IPsec code. Yeah, and then this is kind of interesting. So there's a bunch of stuff that Max has done himself there that's coming in via that branch, but there's also a bunch of work by Alexander Gall. So this is the upstreaming of his layer 2 VPN application he's developed at Switch in Switzerland. So Alex was basically the first ever Snabb user hacker, if I recall correctly. Like, wow! And he's developed a couple of really cool applications himself. He works in an ISP in Switzerland, and the cool thing about Snabb here was that he's running a network, but he can also build his own network equipment this way. So what we see here actually is work that spans back a bit, right? You look at these commits. There's something from 3 weeks ago, 3 months ago, 6 months ago, 7, 8 months, a year. Pardon the kids playing playing in the next room. A year ago, 2 years ago. So this is code that he's been developing for quite a while, right? Over the last couple of years, and it's coming upstream now. So the way that you normally develop an application with Snabb is you kind of create a fork where you're going to do your work, and then you can do anything you want on that. Normally you would just add a subdirectory where your application sits, but if you need to make any kind of changes in the core of Snabb or anything, you can do that because you have a fork. You can change everything, and what you normally do is work downstream while you develop your application. And then once you reach a certain point of maturity and you want to share it more widely, then you can upstream it. And in Alex's case, he's already taken a lot of specific smaller things and upstream them individually. So a lot of the work that he's done has, on the Snabb core, has already come upstream. He's prepared those specially. But what this is his whole application then later flowing upstream. And as an application developer, you don't have to upstream your stuff. You can just work downstream, but the advantage of sending it upstream is that then the code is in a kind of a mono repo with everybody else's applications, and everybody can see the code. If anybody wants to make a large, if someone wants to make a large kind of global change to the code base, then they can update your code at the same time, and all of the upstream testing will be applied and all that kind of thing. So there's some definite advantages in sending code upstream. And you know, that's what Alex is doing here. So it's cool. It's a nice milestone to get Alex's VPN application upstream in the main Snabb repository, where we can, you know, address it with all of our tests and benchmarks and everything. But that's not everything. So what else do we have? We also have a bunch of code that I pulled from Andy Winger. So they also have a lightweight address family translator application. Oops, what the hell is that? Sorry, I got no idea. I don't actually follow stocks and things. I don't know why my Mac has popped that up. Go away. Yeah, so they have a kind of product for doing IPv6, IPv4 address translation, and this is they also developed that downstream, but they have already upstreamed it in the past. But you know, they do a kind of a product release cycle, and during that time they're working quite intensely on their own branch, and then when things reach a kind of a stable point, they tend to ship code upstream, so that we also have it you know, available for testing and to see everything and distribute it through the main repository as well. So the Snabb master branch I like to think of as the trailing edge. It's the code that has reached some kind of a consensus. It's the code that should be shared more widely, and generally the stuff being really actively maintained or actively developed that doesn't live on the master branch, that lives somewhere downstream on a more specific branch, and then once it reaches a certain point of maturity, it comes upstream, which is a nice decentralized way to work. It means that any number of people can be developing at any kind of furious pace they like, and they only kind of they synchronize in a nice way. They're not standing on each other's feet and toes. I like that way of working anyway. So there we have code from Andy and his colleagues going back. Diego's code from 4 months ago, Jessica's code from 4 months ago. If we scroll down, 4 months, yeah, so go all the way down, some months at least. I have more history. Anyway, that's just a little view on the Git level of stuff that I've already merged for this release. So that's kind of the headline for stuff that's going in. And then if we would also have a look now at what we have, if there's anything else I should pull before we finalize this pull request. We're just going to open another tab and see if Andy or Max have batched any more changes that I'm supposed to take. And I believe, yeah, so Max has a pull request open to land a batch of changes on the next branch. So what do we have here? Took some long-running test cases and toned them down in the default setup, and had merged this and got some IPsec fixes. But yeah, I mean, I've looked at this PR before, and I saw that there was some back and forth between Max and Andy, where there was a change here that there was a change that Max had on his branch that also affected something that Andy and the guys were working on a code that they had written, and they were discussing whether that was the right way to do it. And I think that what happened was that Max took that change and spun it off onto a PR of its own here, I think, and reverted it from his branch. So there's this change here anyway is a change that was originally on this branch, and you know, it got the thing with these pull requests is it exposes the code to review upstream. People can see what they think, and that was a change that was worthy of more discussion. So it got reverted off this branch and spun off onto a PR of its own. So what I'm going to do now is I'm going to merge this branch from Max, and before making a release, I'm going to sync up on whether this is something that we should also slip in, or whether it's not important enough, and whether we take it in the next release. So what we're going to do now is merge this branch and ask. Well, we can check on the status of that ourselves as well. give it, first we'll do a merge. And the way that I normally do that is I hop onto my next branch, I fetch the latest from the Snabb repository, which is where all of the branches are, and I say git merge with no fast forward because I want a merge commit, and with no commit because I want to see the changes before I want to be able to browse the diff before I commit, and I want to do maxes. That branch I want to merge. Automatic merge went well, so there were no conflicts. Stopped before committing as requested. Okay, fine. So now we hop back into Emacs, and we just sanity. As I say, I only sanity check the stuff that comes from Max and Andy, and this is similar to the Linux model, right? There's a chain of people that are aggregating changes together, and once these people have been working together for a while, it's a bit more streamlined. They've kind of reached an agreement on a lot of ways that things are done. So I'm gonna just look here at core.packet. That's that's one of the most important modules in the system. So what happened here? The resize function now returns a packet. Oh, it doesn't seem very controversial anyway. We have, while we're here, I'm just going to open up this this file because it's fun. This is some assembler code for doing AES encryption, and I got some help with this from Peter Corley, who's a kind of a RaptorJIT guru and kind of assembler programming guru, and it's interesting. So to get really good performance of AES encryption on Intel processors, there are instruction set extensions you need to use called AES-NI, but it's not like an AES encrypt instruction. It's actually just a very specific mathematical operation that gets offloaded. So you kind of need to still actually write the code for AES encryption. You need to write it in assembler, and you need to make use of this very specific instruction to make it run fast. And Intel published some reference code for how to do that, but it's really long and it's really kind of copy-pasty. And I wasn't very happy about kind of taking that in verbatim, and I also didn't want to do everything from scratch. So the compromise we came to was just to refactor it. So this is actually a pretty small program. This is only about 500 lines of code, and it just uses this DNASM assembler to factor things in a nicer way. So it actually generates the same machine code as the Intel reference implementation, but it does it in a much shorter way. So if you open up the Intel code, it's thousands of lines of code, and they're very repetitive, and they've been kind of copy and pasted, which is completely fine for reference code that mostly exists just to demonstrate what the performance should be. But it's not so much fun for something you're actually going to be checking into a repository, for a project you love and care about. So that's why we took the pains there to refactor that code, so that all of the kind of the unrolling of the encryption operations is done in loops. We have Lua code here, and the Lua code with this DNASM assembler is generating machine code as a side effect. So anyway, it's nice. And if a later CPU generation comes along that has a different optimal number of parallel encryption operations you should be doing or something, then we'll be mostly just tweaking constants in our code, whereas Intel will presumably write thousands more lines, a separate reference implementation for every processor, and so on. So I don't know the answer. The question is about the details of this code. I don't have the details of this swapped in. I mean, this is an AES implementation that we use for IPsec, and it runs crazy fast. I think the last time I benchmarked it was on Haswell. It's really fast. Just the same performance that the Intel reference implementation has, which totally smokes everything else on x86. It's nice. Anyway, that was a digression. So there was a change to the core packet module, which was just to put a return value there. Right now, I'm not gonna worry about tracking that down. It doesn't seem like that's going to cause anybody any problems. There was no return value before. Now it returns the packet. That seems quite fine. And then there are just some small updates to code that uses IPsec. Yeah. So I mean, Max is building an IPsec VPN with Snabb, so he is the one who has the he's the one who has the best kind of view on the current ongoing development of all IPsec code. So I'm taking him at his word on this and bringing this in. It's all got nice test coverage. This pull request is improving. Is improving the test coverage as well. So this all looks nice. So that's the level of detail I'm going into as the kind of the maintainer of the next branch. This came from somebody I trust. It's touching code that I know that they understand very well, and the only thing that kind of jumps out is this, which is quite innocuous. So it all looks fine. So I'm gonna say merge, and by convention I put the pull request number here so that GitHub can cross-reference it. So if I write number 1267 there, then this commit will be on GitHub. This merge commit will be linked with that pull request, which is nice. It's nice to be able to navigate things and keep track of. So I don't need to kill an Emacs. I do that. Okay, and I'm going to push this now. And now we can actually create that pull request. Because now this should all update real time, unless I'm mistaken. Do we get, let's scroll down and see if we got those latest commits too. 1265, is that the one that we just merged? No, 1267. Do I dare press refresh here and see what happens? Yes. Okay, nuked all of our text, but whatever. $12.67, good, okay. Yes, so this is a pull request covering everything. And we got all of that text back, which is lovely. And you know, I have this this extension, Lazarus or whatever it's called, for reviving text. This is just fantastic. This is a release candidate for the 2018.01. Kabang! And we will ask about that. Ask about that. Clunk. Fine. So now that I've created that pull request, it's going to get benchmarked like crazy. Like a week worth of CPU time is going to be spent on a bunch of servers to smash that in various ways. So we're going to be able to see if the performance differs in any significant and interesting way from the previous release, and if that all looks good and if everybody else is happy, then we will. Then Max is the one who owns the master branch. So so this is a pull request from the next branch which I maintain to the master branch which Max maintains. He's the release manager. So ultimately it's up to him if the release is okay. If they're happy, I will at least say that I'm happy, and he can decide what to do with this, whether anything else should be changed. Good. We've done that. Well, we've done both of those things, right? So the next thing that we're going to do is, so the huge thing that I'm looking forward to doing in Snabbland right now is switching from LuaJIT to RaptorJIT. and this is big and small. It's small in the sense that RaptorJIT and LuaJIT are very similar. Not very much has changed in the optimizations and that kind of thing. Most of the changes in the JIT behavior in RaptorJIT are actually ports of things that we already did. Oh, and let's update our live streaming status. Ta-da! Oops, did I do the wrong line? Oh, that's right. Yes, now our status says that we're updating RaptorJIT branch for the next release. Sorry. Switching Snabb from LuaJIT to RaptorJIT is both big and small. It's small in the sense that the optimizations, the JIT behavior in RaptorJIT and the LuaJIT that we use in Snabb are very similar, because when we've had problems we need to fix and things we want to improve, we've often implemented them in Snabb on our own fork of LuaJIT, and then from there we ported them over to RaptorJIT. So while RaptorJIT has diverged a little bit from the upstream LuaJIT, it hasn't diverged much from the kind of the downstream LuaJIT that we use in Snabb. They're pretty similar. The biggest change though is that the tooling is all different. So LuaJIT has a profiler, it has a jit.v, it has a jit.dump, and these commands that make the process generate a bunch of ASCII diagnostic stuff. And I nuked all of that in RaptorJIT for a variety of reasons. One being that a lot of that code is too expensive to use in a lot of interesting environments, like in production environments or major benchmarking environments, which sucks because those are the environments where you most want diagnostic information. So I replaced all those kind of all those ASCII introspective features with other kind of binary logging features. So when we merge RaptorJIT into Snabb, everyone's going to have to use different tools to do their troubleshooting. And I've done a tremendous amount of work on those tools, and Max has also been working with those tools over the last over the last year or so. And now it's the time to meet some Snabb hackers and look them in the eye at FOSDEM and show them how they work, and hopefully get everybody happy. Hopefully everyone will love the new tools. Anyway, so big and small. Small change to the JIT behavior, big change to the way that we will do troubleshooting and diagnostics. But it's worth emphasizing as well with Snabb, we have a distributed development model. So again, so Alex has been developing his VPN downstream for like a couple of years. So even if we would merge RaptorJIT support into Snabb master branch next month, for example, then Alex decides when he's going to merge that downstream into his branch. So if he's really busy with something, doesn't have much time, or is really focused on some other kind of milestone for his project, he can just wait with pulling all that stuff from the master branch for a month or 2 months or 3 months or 4 months or whatever. And everybody does everything on their own timetables. We're all the masters of our own branches. So it's a little bit like the Linux world in that case. In Linux, there have been times where Linus took some changes upstream. Like if you think a long time back, there were a lot of memory management changes where I think basically Red Hat stopped pulling from Linus for a year or something because they just didn't want to deploy the code that he'd merged at that time, and they would just backport the stuff they needed and everything. Anyway, it's the distributed development model, which is surprisingly uncommon because I find it very natural and I like it a lot. Anyway, when I say update the branch, I want to pull the latest changes from RaptorJIT because I've done some changes on RaptorJIT upstream. In particular, I cherry-picked all the new changes from LuaJIT and ported them over to RaptorJIT, all the fixes, and I want to get them into Snabb. And I also want to look specifically at a test failure that I had. So right now I have a pull request open for merging RaptorJIT support into Snabb and replacing LuaJIT, and that got a failure on CI. So let's see what that problem was. That's what I want to do first, to see what that problem was. And then we'll also pull some changes. A whole bunch of errors. Okay, so there's audit log could not be opened. Okay, so there's some kind of a bug on that branch with doing the audit logging, which is a new RaptorJIT feature. Okay, fine. So that looks really easy to reproduce. This is a unit test failing here, the core.app unit test. So I will run that. And let's just check which branch name we're talking about there. For that pull request, it is a branch called RaptorJIT upstream. So we will hop over there. so Git just told me that I have a new commit compared with upstream. Okay, so I'm going to push what I have. So look at that again. This is something we did on an earlier stream. Yeah, so there was a problem with the audit log feature with the version that that I have on this branch. So it's a little bit tricky actually. So the audit log has not landed upstream in RaptorJIT yet, and I guess I should land that. In a perfect world, I would land that on RaptorJIT master right now, and then merge RaptorJIT master into Snabb. But I'm going to do it the other way around. I'm going to get all the changes that I want on this Snabb branch to run the version of RaptorJIT that I want, and then I'm going to worry about making sure that all of those are upstream also on the RaptorJIT master branch. So for right now, I'm going to see if I can reproduce that problem on the code that we have now. And we can be a bit more specific about our status as well, can't we? We can say there we go. Yes. We run the Snabb shell and tell it to run a unit test of the core.app module. It's a failure that we saw before. It is testing the basic engine with so I didn't get the error there. What about if we check out the version of this that the CI was testing? Sorry, we better do a build at the top level because we're changing our JIT compiler. That's interesting. So I didn't get that error that CI reported. So I think what we'll do now is we'll just pull the latest code over to this branch, and then we'll update the pull request, and then we'll, with everything being in the state that we want it to be, then we'll see if we still get the error and chase it in from there. So the goal right now is just to pull in the latest of everything in RaptorJIT. So over to RaptorJIT. If we hop onto our trick is we want the RaptorJIT master branch. We also want the RaptorJIT audit log branch, which is a feature that is this close to being upstream on RaptorJIT. So let's just first we'll go over to so now we're on the RaptorJIT repository, and what we're going to do is go onto the audit log branch, pull in all the latest changes from the master branch, make sure that's in a good state, and then that will represent the code that we want in Snabb, and possibly also the code that should go upstream onto RaptorJIT. So we're updating the audit log branch now on RaptorJIT. Now what has happened here? We merged from master a couple of weeks ago. Let's see if there's anything new on master. Yes. Okay, so we just did a merge from the RaptorJIT master branch onto the RaptorJIT audit log branch, which is catching up on some changes that had landed on master, and this appears to be the fixes that I ported over from LuaJIT. So that's fine. So this branch should contain the code that we want now. So let's see if it works. If we just write nix build in the RaptorJIT directory, then it should compile and run the test suite with all different optimization settings, with JIT turned off and at each different optimization level, and just see that the test suite passes, which it does on all of those levels. So this seems to be in kind of reasonable state. So I'm going to push this to my audit log branch. Separately, we're going to pull request that to RaptorJIT master. It may be the right time to merge it. Just a question of whether there were any. Sometimes when you've been developing a feature for a long time, off on a branch of its own, you're pulling in stuff from master all the time. I've probably been maintaining that branch for a year or something like that, and the feature I'm developing itself is certainly ready to go upstream. The only question will be whether I made any other changes on that branch that should be considered in their own right. Is there any controversial change that I made to a core file? If so, then I should spin that out and submit it as a pull request of its own to make sure that that change is well thought out, and then land that. And then, if there are no objections, if it's not a bad idea, then to land it all together. So, yeah. So when you're developing a feature downstream, sometimes you're not strictly staying on one topic, because sometimes you need to touch other files here, there, and everywhere. Some changes are big, and in those cases, what I tend to do is get it all into a good state, and then figure out what are the extra changes that are just piggybacking their way along, and then spin those out into their own branches and have them reviewed separately and treat them as dependencies to merging the main thing. It's kind of my Git workflow. So anyway, now my RaptorJIT repository is up to date, so we're going to go back to Snabb, and we're going to try to remember or find in our shell history the incantation to pull a subtree, which we have. Git subtree pull. So what we're saying to Git is we have this other. So we're in the Snabb repository now. We're saying we want to pull RaptorJIT from the audit log branch in this case, and we want to mount that as lib/luajit. We should rename to RaptorJIT. But anyway, so the thing here is that the Snabb repository will actually include the RaptorJIT repository and all of its kind of Git history, all the commits and everything. So the Snabb repository becomes a kind of a union of its own code and also the JIT compiler. And we also do this with ljsyscall. And we got a conflict in this case in libluajit raptorjit.next. Which was nothing significant. So I'll revert that. Didn't matter. How are we now? No conflicts now. So we will commit that. I have to check that is accurate. Okay, we're in a detached head state in Git. So you might recall I went on my branch and I hopped to a different commit. And that's this detached head state where you're just working on some random commit. So now I actually want to go back and put this on top of where we really want it to be, and that's a rebase. And to get rebase onto audit log upstream. Why didn't that work? Rather than troubleshoot that now, we'll just do the merge again because it was so easy. We will say git checkout RaptorJIT upstream. This is the branch that we want to be on. And then we'll do that same merge again. And we'll resolve that same conflict again. And we'll do a commit. Oops, didn't have the old command. Looks fine. Does it build? Yes. Tests don't look seg faults. Okay, so I merged some breakage here. Interesting. Now let's try a simple test. Oh, I didn't necessarily rebuild. Okay. Okay, so it's crashing, and in some really simple way by the look of it as well. So we're just going to troubleshoot that right here and now. So first we're going to make sure that we're building with debug information in here. Oops, in here rather. Like that. Rebuild the virtual machine from scratch with debug symbols enabled. Now rebuild Snabb as well. Okay, all built. And now we see if we get the same error. Oops, it's not unnecessary building. Yes, okay, good. So this is actually really interesting in a couple of ways. So what we're seeing here is a segmentation fault, meaning that we've accessed some memory that in a way that we're not allowed to, either memory that was not mapped, or we wrote to memory that was read-only, or we read from memory that was write-only, or anything like that. That's what a segmentation fault is. And it happened in the audit log of the virtual machine, this new feature that I added in RaptorJIT. It happened in the code where we're logging lexer events. So the point of those log messages is that when source code enters the system, when you load a source file or you enter code at the REPL or anything like that, this gets logged in the audit log, so you have visibility in all the source code that you've been running at different times, which is really nice then when you pull it into the studio development tools to actually be able to find all the source code. But the way that we load code in Snabb is something that perhaps doesn't have test coverage in the RaptorJIT test suite, which is not a source code. Rather, in Snabb we take the source code, we compile it into bytecode, we then turn that bytecode into an ELF object file and link that in. So when we load code in Snabb, there is no source code, there is only bytecode, and I suspect that when I added this logging in the lexer, that this is somehow not a covered case, and we need to make a test and a fix for that on RaptorJIT. Let's just dive into it right now. And as an aside here, I think it might make sense as the default mode for Snabb to actually include source code rather than bytecode, because then it's available for debugging. And if that bloats our binary, we might need to find a very small compression program to put in and store compressed source code. If that actually if that moves the needle on the size of the binary. But anyway, right now we'll just fix this problem and push something that can get tortured by CI, and that we can share with other Snabb hackers on the weekend. So, what does that LJ audit log lex function look like, you ask? Okay, so it was in that log mem that it failed. But we'll just have a little look in GDB actually whether we can get whether we can see was that a null pointer or something like that. Why do I never have the debug info that I expect, the way I expect it in GDB? I don't use GDB every day. It's always a risk that I run the wrong command, or that I don't compile with quite the right flags to get the information that I want. So actually I'm curious now if that was like a null pointer or something like that, and I'm gonna look in the syslog actually, because I think on this machine that seg faults get logged in the syslog with a bit of information about them. Yeah. Segmentation fault at this address, and this instruction, and this this error 4 you can look up somewhere to tell us whether that was a read or a write or an execute. What was the segmentation violation? Okay, what we need to do is figure out that this is not something to log. Where does this get called from? So I think actually what we're looking for here is the code that loads a module from, this is in the parser. I'm just trying to put my head together how the control flow is here. I think what we're looking for now is the code in the code that loads modules from C objects. It's probably in lib package. So when you say require on a module in Lua, one of the things it does is it checks whether there's a C symbol that matches that name, like this. Is there a C symbol like that? And if so, that's bytecodes. So when those are loaded, we don't have source code available, and we better skip those log messages in those cases. So we just got to trace the code for where we do that, where we actually load bytecodes. And that's going to be in this lib package, I think, somewhere. We could do worse than to search for that symbol, actually, where that is referenced. Symbol prefix for bytecode. So where is that referenced? Here, load function. Load buffer and pass in bytecode data. So is load buffer where the action is? Load promising file. So, what do we have here? Mode. What is the mode? Is that saying whether it's a bytecode, whether it's bytecodes or strings? Let us see. Where does it come from? New load passes in null for the mode. So where does the mode come from? We are calling L load buffer this bytecode data that we got out of the C symbol. These arguments. Trace it through. Okay, so we have a mode past. No, sorry, it's buffer X. Notice the mode is going to be null. So where is it going to detect? Where is it going to detect what kind, whether this is bytecode and not source code? Is that up here? Yeah, okay, BC. There's some detection going on. LJ setup is going to return a flag saying whether this is bytecode. So it's going to call BC read, otherwise it's going to call parse. Okay, let's just look at the stack we have again. Where is this getting called? CP in lex setup, this was happening. Lex setup, lex next. Here. Okay, in that call, we're getting our error. Okay, fine. Let me copy that stack trace into an Emacs buffer where it's kind of at our fingertips. We don't keep popping out into tmux. there's that for reference. So, in lexer, started in lexer setup. Now we skip to the end because this is supposed to return a flag saying it was bytecodes. Okay, we have two separate paths here, right? One, this is where we detect it was bytecodes, but I guess that's the other question. If we load bytecodes, should we log the bytecodes? It's probably actually to first approximation. It's probably not the worst idea ever. Anyway, that's another question. Okay, so this went into line 404 we're on. Yeah. Read ahead the first character. And I'm going to hop all the way down and see. That's the one that fails. Can it be the chunk that the is null? Yeah, we saw a funny error. This would be kind of amusing. Briefly, so the thing is, on our you remember our seg fault here? That's the address that faulted. It's a funny looking address, right? It's not 0, it's not a null pointer, but it's actually very low. It's a very suspiciously low, so it might be something relative to 0. What is that in decimal? No, it's big. It's too big to be. Anyway, I was wondering if what we're seeing in the seg fault, because it's a mem copy. Mem copies are written in weird and wonderful ways. So this is the SSE2 mem copy from libc. It might be something that copies backwards. So if you give it a null pointer and a long length, it might actually be that the first byte it accesses is something far at the front, and then your seg fault will give you a funny address. I think it's still plausible. That number doesn't quite make sense to me, but it still seems kind of plausible to me that our problem is that the chunk is null. So where does this chunk get initialized? Let's go back out, all the way back out to LJ load where we were before, when we entered this whole crazy place. No, so it looks like the chunk. You pass in a null chunk name, you get a question mark. That shouldn't be the problem. So which... The answer is not jumping right out at me. So I'm going to look at those sections. So why didn't we get local variables is my next question. Let's just look briefly. Let's rebuild and see if we actually just get the answer right now. Not sure where we lost the local variable information for GDB along the way. We'll see if it was in somewhere easy. The binary is about twice as big now, so there should be a certain amount of debug information in there, right? Actually, I would like to understand why I don't have simple table available there. I don't spend a lot of time debugging Snabb and GDB. We'd figure that out. If we can get something something relevant anyway. If we hop into the large size, is it not? I have an Alex. Anything in there? Chunk name, chunk arg. I have P there. That's nice to know anyway. It doesn't seem like that should be null. Let's just double check that. It is null. Okay. Well, we don't want to log and a null pointer. So that seems like something actually kind of obvious. Go into the lexer. Okay, remember this is just something that hasn't been updated yet. So we're gonna write P there. We got a P by calling this function callback to get some more input. That gave us a pointer to some input. Hang on. Which of these things is dying when we log it? Let us check. Is it the chunk arg or is it the P? Or what is it? Where is our stack trace? Do we have the line information now in the new one? No. I'm not quite sure where we lost that line information after we enabled the debug build on GCC. We did lose it somewhere. It's a pain. Anyway. I have a preliminary theory. My preliminary theory is that this size argument might be garbage. Is it possible? Is it possible that when the VM is loading bytecodes, that it doesn't properly initialize the size argument, and it relies on the bytecodes being well formed and the parser stopping when it should? Is it possible? Yeah, is it possible that size argument has just a silly value? I think we might have seen that, might we? Pardon me, starting again here. Joey, come. My dog, he wants to go out and hang around with other people. He's not satisfied with the coding session. Hey, Joey. Joey. I'd love to get a little second camera. A little furry fellow who usually is sleeping quietly on the floor because he's already had a really big walk. Anyway, I digress. One day I'll introduce my dear dog Joey. For now, run. Yeah, okay, so the problem seems to be that this size argument is total bullshit. So when I wrote the code, I was imagining that the size would be initialized to the amount of input that we got, but I suspect that this is not the case when we're loading bytecodes. Let's see if we can find a smoking gun. I'm maintaining RaptorJIT, but of course it's a fork from LuaJIT, so still about, say, half the code I'm not really familiar with at all yet. And one of those bits is the code that pulls out bytecodes to parse from a C function. Let's see if it gives it a meaningful size or not. And if not, we might just skip logging bytecodes because we're mostly interested in source code anyway. But let's see this anyway. LJ load. rfunc. So we have this thing called lexer_state.rfunc, which is a reader function, which is a C function pointer to something that is gonna supply input. So there's presumably one for getting source code and one for getting bytecodes. So we want to find the one for getting bytecodes. So where does that enter the picture? Reader. This Lua reader is passed around a lot. Where does it come from? Reader file. Okay, there's a reader for files and a reader for strings. Well, that's not what we're interested in, right? We're interested in a reader for bytecodes versus a reader for source code. Maybe it's related. Reading from a string. We have a string reader context. Hey, Joey. Where do we initialize that to size? Just one moment. I'm going to get my dog, I'm going to give him a little bit of comfort while we do this. He can help us because there's sounds coming from outside. And of course, anything that's happening outside, like gates opening and closing, that sounds distinctly like something that he should be involved with. So he's a little bit frustrated. This is Joey. Hey, Joey. Hey, Joey. There's people up there. There's people up there. And Joey, he's had a great big walk. He has everything that he needs, except that there's exciting sounds coming from outside. He'd like to get in on that action, wouldn't you, fella? Wonder if I can get any better coverage of the little fella there. Joey. So we'll take one small moment to see if we can get you in the mix a bit better, hey fella. There you go, hey? Okay, Joe, you're going to help us here. You're going to help us here. Help, not lick, help. Okay. Joey, we were looking for... Okay, this is not a good debugging scenario, Joey. I hope you enjoyed that moment of companionship. Now hop down. Okay. Back to normal. He probably is a little happier now. We hope so. Right, so this string reader context is getting initialized somewhere. Is it getting initialized with a real size or with a rubbish size? Size is initialized. If we go back to the lexer and see where we want to see where the size is applied for bytecodes. If you're loading bytecodes, how do you know how many bytes of bytecodes you have? That should be in lib package, I think. Ha 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 ha. So, if you're loading bytecodes, it seems you always say that you have the maximum possible amount of them. So this explains everything. So if you're loading bytecodes, you say that you have a huge amount of them. You're presumably depending on them being well formed, so that the lexer is going to reach an end of input and it's not going to overread and discover that your memory is not mapped. But in our case, we try to log the input that comes there. We try to log it with a call to a POSIX file API, which does an fwrite. Fwrite tries to do a memcopy of that data. Memcopy is specially optimized for the SSE2 instruction set for whatever CPU was contemporary when Intel wrote the glibc SSE2 routine. For whatever reason, that I believe copies backwards in memory. It copies the last bytes first, and then we get the seg fault at a funny address, a very low but non-zero address. And really it was a memcopy based on a null pointer, but a null pointer and a big length, and it went to the end of the length first. So that's, now everything makes sense. And the only thing that we need to do now is, I think is the simplest thing, because the real intention of that log message is to log source code. We already get bytecode indirectly the way we log the JIT operation. So I think in this case we just don't want to log those messages anyway, so it doesn't really matter to us. It doesn't matter to us particularly that, that we don't have a valid size. So how do we detect that? How do we detect that it's bytecodes that we're dealing with and skip those? So if we look again for this lexer state, is there anything here that tells us that whether we're parsing source code or bytecodes? Okay, yes. We have a mode. So if we hop back into GDB, so I'm doing everything in the same tmux. So every time I switch between Emacs and GDB, I'm like restarting GDB, and that's silly, of course. So let's use another tmux window separately for GDB. GDB. Now we have a GDB tmux screen there and the Snabb separately. And while we're at it, we could update the text as well, right? Because we have that nice little hack. We could say that more specifically, we are fixing RaptorJIT audit log of bytecode. Badoosh. Okay, good. And back to the code. We were now gonna was snish to self-test core.app, and yes, we have a lexer state there. Now, I was expecting that to be either the letter B. Sorry, where do we have that? Mode. I was expecting that to be either B or T, but it's 0, which is a little bit unfortunate. So is that something that's just not updated? Where does the mode get initialized? Load buffer. This is where we kind of enter the whole load buffering thing when we're doing bytecodes. But you know, the thing is, I think that's generic function that will work on either source code or bytecodes. I think it's detecting somewhere along the line. So maybe in the is it in the lex setup? But you know, the other thing is this is happening so early, right? It was in the initialization of the lexer. Maybe it's even going to set the mode here. Nope. So it's trying to just do this read ahead of the first character. So we need to read some text to figure out if it's bytecode or not, because actually further up the C stack we knew if this was bytecode or not, but we then called this this generic function that takes either source or bytecode, so we lost track of that. So now down here and now we need to read a byte in order to figure out if it's bytecode or source code, but when we read that byte we want to log the fact that we read some input, and the logging we would like to somehow not blow up if we get some garbage. Okay, let's just chase it down, find what is a reasonable way to recover that information about whether we're doing source or bytecode. It calls into lex more. And so that's the thing that's failing. The P was not null. It bothers me a bit that somehow in the build process we lose out debug information there. So I would quite like to have it. What we might do now is we'll do two things. We'll print those arguments. We will also say, and I hate myself for writing this, but one way we could detect whether it's bytecodes that we're not interested in perhaps is to see if the size is this bogus value, which was LJ max buff. I don't think that's a good thing, but it is interesting to try just for now. You know, RaptorJIT, they don't put curly braces around things, but I live in fear. We all remember that was an Apple bug where missing curly brace kind of caused all kinds of havoc. So I think in RaptorJIT we're going to put all those curly braces back in. gradually anyway, on new code and on code that we update. I like them. I think that they're worth something. Okay, we're doing printf debugging now, and really we should be doing makefile debugging to see where we lost the debug info, but we'll take that. Don't need to do it clean. Take it later. Oops, I didn't include standard IO. What's that garbage getting printed? Pretell? So we get garbage out instead? Why would that happen? Not for any plausible reason, right? That looks completely fine. Why do we get garbage? Yeah, right. I called printf with the arguments to fprintf. That was silly of me. Let's try that again. So what do we have? We get the first call, we have size 22, and then we get these ones. So it looks like we load a tiny bit of source code, which then probably loads a bunch of bytecode. And these ones we don't want to log. And at the moment, sucky as it sounds, the only way that we have down there to detect whether it's boring bytecode that we don't want to log, or whether it's source code that we do want to log, is by this length field that bytecodes have this kind of invalid. Well, they specify the maximum length, and that memory isn't actually mapped, so it's kind of it's not a real value. Sorry, but let's. How big are we talking there? Okay, 2 gigabytes. Well, that's actually okay. We can use that as a sentinel. We don't need to support loading a 2 gigabyte string of Lua code in one go, so that's actually okay. It's not ideal, but we will say that if the value is that, then we're considering it to be bytecode. So, oh yeah, right. I mean, we already did that, so it's actually working. So let's get rid of that printout now. Not completely happy about that, but again, this is an example of the kind of the upstream downstream workflow. So now we're working on RaptorJIT in a downstream project, which is Snabb, where we've merged it in. So the focus now is to just write the changes that work well for Snabb, and then when we have everything working well for Snabb, the question is how to get everything that we have done for Snabb upstream into RaptorJIT. This can all be done asynchronously, and if we commit something here, there's no risk of it like suddenly appearing on RaptorJIT master, because the only way to get there involves, doing pull requests and checking code. So this is what we're doing here is something expedient that works for Snabb, and the main focus there is actually to get something testable right now, because this is code that's being prepared for an initial merge. So anyway, let's be a bit more explicit there. Okay. Let's run a Snabb interactive shell. Now we should run that as root. Require memory self-test. The self-test might actually exit. I don't remember. That ended in a segmentation fault. Is that the same one or is that another one? Try another couple of those. That one, seg faults. And what about the packet self-test? No, that works. So, I'm not sure if we're looking at the same problem or a different problem. Let us do that in GDB, hey? This is something else. This is code that's running in the interpreter. Doing the require logic. Loading a module. Something with the FFI. Getting a interesting. Testing automatic remapping of DMA memory. So, well, okay, this is something really specific. Snabb does this cool trick with DMA memory. I'll just briefly explain. So, when we want to do in Snabb, when we want to send and receive network packets, we don't talk to the kernel for that. We talk directly to the network card, and we need to have a common vocabulary with the network card, and we use physical addresses for that. So when we allocate memory that we want to use for a network buffer, we use mlock to pin it to the location it's already in. Then we go and grovel in a sysfs or procfs file to figure out for that virtual address what is the physical address, and then we remap the virtual address to be a tagged version of the physical address. So these are just pointer addresses, but they have a very specific meaning in Snabb. So this 5 in that position is a type tag saying that this is DMA memory. So any memory that we're going to use for DMA, we go out and we remap at an address that has a 5 there. And implicitly in DMA memory, the rest of the bits is the physical address of the memory. So the virtual address is this thing with a 5, and the physical address is that. So if we want to convert from a virtual address to a physical address, because we have a pointer in our own memory space we want to translate into the address that a network card will be able to do DMA on it, we just strip off the 5. Which is a little, it's similar to the way kind of programming language runtime systems are sometimes done. So we do type tagging to a certain extent, well, only in that way for our DMA purposes, and it gives us a really, really fast conversion from virtual to physical addresses. Right? We just mask off that 5, and we have the physical address. So it's really nice. And, actually, hardware CPUs have a feature called the IOMMU that's meant to take care of all of this and give you a common address space. Common ground with the network card, be able to export your virtual address space to the network card. But at least when we were writing this code, and possibly as well today, IOMMUs were a bit of a world of pain. There were performance bugs in the hardware, there were funny bugs in the kernel support and everything. So we've I think we said we'd give it 5 years. Maybe it's been 5 years now. I don't know. But anyway, we're using physical addresses and staying away from the IOMMU most of the time, based on our experience. Anyway. So this, and then this is another cool thing, digressing away. Automatic mapping of DMA memory. So the idea here is that if you have some DMA memory, you should be able to have multiple Snabb processes that are all allocating memory for DMA, and they should be able to share memory. So if you have a pointer to a packet, and one Snabb process passes it to another process by any means at all, like puts it in a shared memory ring buffer or writes to a socket or whatever, an address like this should be valid not just in the Snabb process that it was allocated in, but in all kind of sibling processes. And the way that we implement that is that if we have a sig-segv handler, so when Snabb gets a segmentation violation, we look at the address that segfaulted, and we look for this 5, and we say, was that a DMA address that segfaulted? If it was a DMA address, if it has that type tag, then before we crash, we make an attempt to dynamically map that memory into the address space. And we do that by looking in a shared memory directory that's in common for a few Snabb processes that specifically want to share memory, and if some other process has allocated that memory, then we map it. So anyway, this is a unit test that allocates a bunch of memory, and then it unmaps it, and then tries to write to it after it's been unmapped, with munmap. And the idea here is that the process should dynamically map that back in, and apparently it didn't happen. But anyway, this looks like another. This is significant, but it looks like a different thing. So I think that we can push this code that we have now and get it subjected to new testing, and we'll assume that there will be at least one test failure for that. But I think the basics have been working. So I think that this is the next step is to push this code and get a new set of test results for it. And to do that, we first got to commit just that there. So that we don't want. This we want just that part there, so we stage that specifically. Quite nice in Maggot in Emacs. You can browse through, and we have some changes that are unstaged, and this one is staged, and we would just commit that. And what branch are we on? RaptorJIT upstream branch, we'll push that. Good, okay, the next step is to test that, and there will be at least one other bug to fix. But what I would really like to do is get that in shape that I can very quickly get people up and running with RaptorJIT and Studio at FOSDEM on the weekend, which would be cool. FOSDEM being this huge, thousands of people open source hackers conference that I've never been to. It's over in Belgium, where I've never been before either. Anyway, that's live coding for today. Thanks for joining in with that. That was a kind of a relaxed, going about my business kind of a one. It's a bit different.